Hello everyone, my name is Mr. Bice. I'm with Susquehanna Valley High School here in Concord, New York, and there's my email address. We're doing Unit 7, Lesson 3, Stretch Armstrong. We're going to be stretching functions. If you don't understand what I'm saying, there's the genius who wrote the worksheets, and he explains it. Just scan that QR code. So, vertical stretching of functions. Okay, we shifted things to left and right, up and down, but that doesn't change the dilation. Okay, we're going to be stretching it. Uh, we've seen how to shift the parabolas in a specific direction. Now, the first exercise here will illustrate the concept with 3 related parabolas. Okay, so we're going to use basically x squared minus 4x minus 5. It's a quadratic function. And g and h are defined as the fact that whatever f's answer, we're going to multiply it by 2. And that'll give us g's answer. Whatever f's answer is, we're going to multiply it by 1/2, and that'll give us h's answer. So let's see. Looks like this one we might relate and say that's bigger, and that one we're going to relate and say it is smaller. So just like in yesterday's exercise, if we're going to do g of x, it equals 2 times x squared minus 4x minus 5. And let's try to do this one correctly this time. So it's 2x squared minus 8x minus 10. And then h of x is going to be 1/2 of x squared minus 4x minus 5, which is the same thing as 1/2 x squared minus 2x minus 2.5. Okay, so those are the 3 equations, the original one and the 2 that are modified. Question B says, using your calculator, sketch and label each curve in the set of axes below. So let's pull up the calculator. Here's the calculator, and I put in each of the equations. Now I'm going to change the red one to make it a little thicker line. There's the thin line, there's the thicker line. Go to OK, hit enter. And now, if I hit graph, look. The blue one is the original one. The red one is when it's twice. Looks like it goes down farther. And the half, the black one, is the smaller one. It's wider and doesn't go down as far. Interesting. Now you notice on the question, the x's go from -3 to 7, -20 to +20. Now I'm just going to sketch that over here. I want you to be aware of a couple facts. Number one, there's the fact that both of these, all 3 of them, have the same x-intercepts. And how do we find, second fact is, how do we find the middle of the parabola, the turning point? Well, you just take the x-intercepts and count 1, 2, 3, 4, 5, 6. 6 divided by 2 is 3. 1, 2, 3. On that line is going to be where all the turning points of the parabola is. And there's the sketch. Now you have to be extremely careful with the fact that this one, the original function, is the highest for the minimum, and it's also the most on the outside. I blew that side. Let me correct it. I said I blew the left-hand side because it didn't go through the same x-intercept. They all have the same x-intercept, so it's the widest and it's the highest. The middle one is in between them and is in between. Okay, the red is the narrowest, and let's put labels on. And there are the labels. So what happened here? F of x is the original function. If we make it 2 times it, it goes deeper and it's narrower. If we take half of it, it's shallow and wider. I think I'll ask you a question about that right now, and then write it down. And there are the notes on it. Okay, now, what points did not vary when f was vertically dilated by a factor of 2 1/2? The zeros where it crosses the x-axis. How can we prove it? Just factor the GCF out of the equation and you get the original problem. So let's take a look at that. Oh, of course it is, because that's exactly the same work that I did to find g of x. I distributed the two. Now I just factored it out. Those two things are the same. Sorry about losing my voice. So the vertical dilations of the function are exactly what I told you earlier. Let's take a look at the next page now. Okay, so we have a point negative 312, and it lies on the graph of the function y equals f of x. What happens to the fact that we only take f of x and multiply it by 3? So think of a machine, and this is the function machine, y equals f of x. In goes a 3, negative 3, out comes a 12. Okay, so that's the original function machine. Now, another machine. The other machine says, whatever you do, I can do 3 times bigger. That's what that says. I can do it 3 times bigger, 3 times larger. So if in goes a negative 3, out comes 3 times your answer. 3 times 12 is 36. So we have to think of the negative 3 stays the same, and out comes a 36. Okay, so this is kind of funky. The graph f y equals f of x shown below. Consider the function y equals g of x, defined as g of x. First multiply it by 2, then subtract 3. First take my answer and multiply it by 2. What? How can I find your answer on a graph? Well, I know where I can find the answer. The answer is right there for that point. It's 2. The answer is 2. What's the question? Negative 1, negative 2, negative 3. So the question, negative 3, gives me an answer of 2. So the question for g of x, I'm going to take the answer 2 and multiply it by 2, which is 4. And then subtract the 3. 4 minus 3 is 1. Plot that point. Now remember, because the minus 3 is on the outside, we're not shifting it to left or right, we're shifting it up or down. Now if I take this point, the answer is still 2, and 2 times, well, negative 2, sorry. 2 times negative 2 is negative 4, minus 3 is negative 7. Ooh, that's a big difference. Where's negative 7? Here's negative 7, right there. So since these two are connected, those two have to be connected. And we do the same for the other points. Let me do this one really quick. 2 times 1 is 2, minus 3 is negative 1. 2 times 5 is 10, minus 3 is 7. Right there. And there's the graph. The two transformations have occurred in this graph to produce the graph of G. Okay, in the order, exactly what I described to you. We first multiplied by 2, then subtracted 3. So first a stretch by 2, then a slide down by 3. Graph and label them. So I have to label this as g of x. I labeled the other one as f of x. There's g of x. Okay. If you have any questions, make sure you ask me. Exercise number 4. Function h of x has a range. So you immediately have to think, what is range? Is that the x values or the y values? The range, domain range, x, y. Input, output. Alphabetical order. Okay, so these are the y values. H has a range of 2 to 10. So this is H. That has the range of 2 to 10, not this F part. So what's the range of f of x? Why, you only have to think of what's affecting the y value. What is affecting the y values? Well, we said that if this is bigger than 1, it's going to be going up faster. Uh-oh, this is a shift up 8. Okay, so remember, the first thing we have to do is multiply by 3/2 and then add 8. What are you talking about? Here, first multiply by 2, then subtract 3. First do the multiplication, then do the addition or subtraction. So that's all I have to do here. I'm going to grab the 2 and say, what is 3/2 of 2 plus 8? That's 3 plus 8, which is 11. Now, I'm going to grab the 10 and say, what is 3/2 of 10 plus 8? What did you do? Ever I saw h of x, I put in its answer. Okay, so this is 5 plus 8, which is 13. No, it's not. Try again, Mr. Bryce. The 5 part was the first part, so it's 5 times 3 is 15. So it's 15 plus 8, and that is 23. So I didn't answer the question. It is from 11 to 23. I didn't even see it with multiple choice. I guess I'm better to be good than lucky. Last question, exercise number 5. If the quadratic function g of x has a y-intercept of 12, I said 12, which of the following is true about h of x, which is 3 times g of x minus 5? Well, I just take the output, take the answer. That's all that means. Just take the answer. 3 times 12 minus 5. So that's 36 minus 5, which is 31. It has a y-intercept of 31. Like I said, better to be good than lucky. Okay, ladies and gentlemen, that finishes lesson 3. Of course, the next 2 pages